Welcome to 5.01. We're going to graph and identify key features of exponential functions, including simple transformations. So you'll notice there's some new terms here which we're going to talk about, exponential functions being the key one. And to start off, we're going to just look at a really simple situation and kind of explore it a little bit. Start off, sketch a graph of f of x equals 2 to the x. And I've created a mock little graph for you. And so go ahead, most likely what you're going to want to do is make a table of values and plug in values for x and see what you get. So go ahead and try that on your own, pause the video, and then we'll take a look. Okay, so most likely you're going to want to start off just noticing that the function is taking 2 and raising it to the power x. And we're going to want to plug in whole values here because it's going to be a lot easier for us to just do, say, 2 to the second power than it would be to do 2 to the 1/2 power by hand at least. Now we could use a calculator to do that, but we want to just get an idea of what this graph will look like. So most likely you want to start it at 0, and maybe you didn't, but that's okay. Let's just start at 0. So 2 to the 0 is just going to be 1. So I can plot my first point right there. And then maybe we move on. Let's go 2 to the first power. It's going to be 2. And so 2 to the first power is 2. And maybe this wasn't clear. This should have been a 2 here. You could have figured that out by counting up to the 10. So here's my second point. And then maybe I keep moving on. So 2, when x is 2, I have 2 to the second power, and that is 2 times 2, which is 4, right? 2 times itself. So then we'll be right here. All right, and so then maybe we jump up. We can do 2 to the 4th. So that will be 2 times 2 times 2 times 2. And that will end up being 16. So 2 to the 4th is 16. Well, that's actually way out of our ballpark, right? 10, 12. So we got our 10, 12, 14, 16 would be way up there. And we might want to squeeze in 3 here. So 2 to the 3rd, 2 times 2 times 2, which is 8. And so we can start to see the basic pattern here. What's important is to realize that we can actually plug in negative values. So let's try -1. Now, this may be something that you've forgotten, so we'll make sure we review it here. So I have 2 to the -1 power. And we want to remember that when we raise something to a negative power, there's a certain something that happens. So let's just consider 2 to the -1. And if you were to do 2 to the -1 times 2 to the +1, you would want that to be 2 to the 0, right? Because you'd add the exponents. Well, what's 2 to the 0? 2 to the 0 is 1. 2 to the 1 is 2. And so you're trying to figure out, well, what is 2 to the -1? It's just as simple as saying, what times 2 equals 1? And you have to multiply by the reciprocal. So 2 to the -1 is going to be 1 over 2 to the +1. So the rule that we have is that 2 to a negative power, so I'll say 2 to a -x, is the same as doing 1 over 2 to the positive value. So this is an important thing to remember if you don't remember it. And that works for any exponent. Okay? So coming back here, 2 to the -1 is going to be 1 over 2 to the 1, which is 1 over 2. So I'll be down here. All right, now let's go to -2. 2 to the negative 2 is going to be 1 over 2 squared. Well, 1 over 2 squared is 1 over 4. So 1/4. Probably should be closer there. Now let's think about what happens if you were to plug in a really big negative number. Let's say you were to plug in, negative 10. What's 2 to the negative 10? Is it going to be positive or negative? Well, it's going to be 1 over 2 to the 10. And 2 to the 10 is a really big positive number, so this is going to be a really small positive number because it's 1 divided by 2 to the 10th. So even if we went to a really big negative x value, I'd still be positive, so my graph will look something like that. We'll never quite touch 0. Okay? And this is an exponential function. An exponential function is where our independent variable, x, is treated as an exponent. And that's where we get exponential from. Okay? So this is our first look at an exponential function, and we're going to do a lot more. So what I want you to do right now is pause the video, just take a look at this function, and notice some of the key features. So what is happening as I move towards the right? What is happening as I move towards the left? As x gets bigger or as x gets more negative? What's the y-intercept? You'll notice as x moves to the right, it grows faster and faster and faster. Right? It's getting steeper. So it's pretty shallow here. It's getting steeper, steeper, even steeper. As I move to the left, it's getting closer and closer to a straight line, right? Almost touches 0, but never quite does. Okay? So a couple of things to just take note of. You've graphed your first exponential function, and now we're going to start looking at some more complex cases. So what is an exponential function? Well, I just talked about it. An exponential function is a function where the independent variable is in the exponent. And so the value that's going to be changing, that we're going to be changing, is going to be the exponent itself. So the basic form of an exponential function is a times b to the x minus k plus c. That might look really confusing. Don't worry. We just use a, b, k, and c as replacement variables for constants. So when we actually see a function, these are all going to have specific values. So an example might be f of x is equal to 3 times 2 to the x plus 1. And here, the a value, mark them off, the a value is 3, the b value is 2, the k value, right, it's not existing, right? It's minus 0, so the k value is 0, and the c value is 1. And so what we're going to do is we're going to start to explore how changing these different values will change our exponential function, and what will make it look like. And in doing so, we're going to try out a couple of different variations. We're going to finish this up in class, but to get started, what we're going to do is we're going to graph a bunch of different functions, exponential functions, and your goal is going to be to come up with a conjecture about how changing, some of these constants will change the way the function looks. Here's what we're going to do. You're going to graph these 5 functions. So make a big graph on your paper and go ahead and graph them out. Okay? And you might want to make a table to help yourself graph these out. So you can make one big table, right? You're going to plug in some x values, and one by one you're going to want to graph f of x, g of x, p of x, q of x, and L of x. And so you can make this one big table to help you organize all your values, and that might allow you to see things a little bit more clearly. I want you to try and use values on both sides, right? Positive and negative. So start with 0 and maybe work your way up and then work your way down. And be careful with these, okay? And if you need to, right, you can go in and use a calculator to make sure you're computing these correctly. So go through and graph each one and label each of these graphs. So when you've graphed f of x, whatever it looks like, make sure you label that that's f of x, okay? And once you're all done with these graphs, I'm going to ask you a couple questions, and that's going to help us start to realize what it is, what are the characteristics of exponential functions. So right now, go ahead and pause the video and graph these out, and then press play, and we'll talk about a couple of different things. So I hope that went well. Remember to make sure that you can check your answers are correct for the graphs of each function. You can go online, use Wolfram Alpha if you need to, and use your table as well, so you can kind of see what's happening. Now what you want to do is answer these two questions. So what happens when the c constant changes, and what happens when the a constant changes? So look at the different functions that you graphed and notice which ones the c constant is changing in. And then notice which ones the a constant is changing in, and try and figure out, by looking at the graph, what is happening when the c constant changes. What happens when the a constant changes? Okay? So in your comment, if you have a question that you want to ask, that's fine, but all that I'm going to require for tonight is that you answer both these questions. So you should have 1, and then your answer, 2, and then your answer. And if in your answer you were a little confused about something, you weren't sure, say, here's what I think, but I'm not sure because of this. Okay, so be as specific as you possibly can. And tomorrow we're going to finish up looking at all the different things that can change in an exponential function and making sure we understand what that will do to our graph and our behavior of the function.